Welcome, everybody. I want to thank the organizers of PyOhio. They're an amazing crew of people. Don't go changing. Love being here. It's been one of my favorite conferences, regional conferences that's out there. I've been coming off and on since the very first one in 2008. Today we're going to be talking about the mastering the Zen of the dev experience. And this is something that's easy for me to talk about because I'm very passionate about the developer experience. I want our developers to have an easy experience out of the box. What may confuse many of you is that in the same line I use the word Kubernetes and simplicity. So I hope to explain what that is all about along the way. Again, my name is CalvinHendryx-Parker. I'm CTO and co-founder of 6 Feet Up. I'm also co-founder of the Indianapolis Python user group IndyPy. If you're in the area, look us up. We have awesome meetings and lots of great community. There's some IndyPy folks in the room today. Thank you all for your support and coming and hanging out with me and checking this all out. I felt like I needed to put in some obligatory cats and dogs, so that is my cat. It is a 20-pound Maine Coon. He's a big guy. He does not like being picked up like that. So he's actually quite displeased with me right now. And there's the dog. The dog is a very happy dog. His name is Mushu, and he loves hanging out with everybody. He's basically me in dog form. He loves all the people, all the dogs, all the things, and all the good times. So what I'm going to be talking about today is actually a framework of tools that we put together. It's actually on our GitHub account. So that URL or that QR code will take you to our project called SCAF. So SCAF is this open source tooling. It's heavily based around cookie cutter. It originally started its life as the Django cookie cutter repository that I forked and then added my opinions to it. So I kind of took an opinionated thing and made it even more opinionated, and then we took it to the next level of opinions, as I'll go into. But if you're curious about it, yeah, you can scan that. There will be links at the end of the slides as well for these same things. So if you don't catch them here, you can get them there. Did I not? Oh, shoot. Well, and at the end, I have a link to this slide deck is also on that same 6 Feet Up organization's GitHub repository. I will compile the compiled PDF version of the slides is not up there yet. It'll be there shortly thereafter, but the markdown raw version of this is currently up and live, and there's instructions if you want to run it yourself. But let's dive on in. One of the things I've considered over the years is how long it takes a developer to get productive on a project. If you get hired on to a new company as a brand new developer and they hand you your MacBook, Linux, Windows, laptop, desktop, whatever the case may be, your workstation, and it is a clean, fresh machine, what is the average time before you are able to make a pull request or get some kind of line of code either into a staging environment or all the way to production? Like, how can we shorten that time span as much as possible? The idea would be to be set up in a few minutes. I mean, my ultimate user story would be I git clone and I run some tool. In this case, I have an example here of Tilt, and I'm coding, like just on my machine, fixing bugs. They could hand me some easy, green belt bugs, and away I go. Another thing that I want to focus on is like sometimes the machines don't have enough resources potentially to run the giant stack of software that may be the big thing that you work on for your organization. Not everyone has small, lean, microservices-based stuff, so that you'd have enough RAM and resources, CPU, to run the whole application. And also part of this is how do we package this up in a way that is the same for me, the same for another developer who's sitting beside me, the same is actually on like the sandbox or the testing instances or the staging instances, and the same that actually goes into production. Containerized seems to be, to me, the way this goes. I started, probably I almost consider myself a little bit late to the game on containers. I was kind of a holdout, waiting to see how this all played out. And it wasn't until about 2020 when I kind of adopted containers as like a great way for people to work. But I think a lot of people have not found a great way to work with containers on their local desktop instances. A lot of times you may be locally developing on the local file system, but maybe you deploy into containers on some environment someplace else. Oh man, it would be nice if those were the same, wouldn't it? And then we'd also be able to have things like continuous integration, continuous deployment, be able to get quick feedback loops. I mean, wouldn't it be amazing if you can like test your code locally, run your local tests, have it committed, run those local tests or those tests in a CI environment, and then things can just deploy and release, and you can always be rolling forward instead of hopefully not having to roll back. It'd also be nice and this is my laundry list of wishes for what I would think this developer experience should be like, is if you could have some way to have automatic, preview release environments so that I can push my branch and then another person could go look at it somehow easily without having to come over to my desktop and look at it on my computer. And then all this includes using the same tools to debug for the dev environment, the QA environment, or even production environments. If that set of tooling could be familiar to me so that my muscle memory just works when I walk up to one of those environments and want to either pull that container down, which is another benefit of containers, I can take the same exact version of that container and bring it to my local machine, set it up with my debug tools, and actually dive in and debug these issues. Actually, how many people in the room use a debugger in their day-to-day development process? Okay, everyone should be. I would highly recommend, and I'll show you how to do it. I'm going to do a live demo. That's one of the things I love doing on stage. I will do a live demo of setting up a debugger and actually debugging containers running inside of a Kubernetes cluster right up here on this stage. So again, that's my ideal, where I see this all going. And then when I say a few minutes, I mean it. I think the ideal should be from the time you're onboarded and I hand you your laptop, in an hour, you should have your project up and running. And how many people have that experience today? And within 1 hour, they could have their code base up and running locally. Yeah, it's not common, and I think it should be way more common. And I'm going to show you how. So we decided to scratch our own itch. Taking some tools we have in the community, there's lots of great bits and pieces and Lego blocks that are all laying around that can enable and unlock this kind of behavior. So again, I mentioned dev laptops can be underpowered. You can't run these large software stacks. It's difficult to do remote debugging on some of these environments. It's hard to either forward ports back, or maybe you're not familiar with doing it. A lot of times you can run into Docker permission issues if you've ever run into using Docker Compose locally, and whether you're on a Mac or you're on Linux, it can be a different experience because of the ownership of the files and what Docker Desktop is doing under the covers for you. I want to, again, normalize this experience across all the environments. So I don't care if you're on Linux or if you're on a Mac or on Windows. It should just work. And then, again, a little support for developing inside of containers. That's been a tricky bit for most people because of synchronization issues. How do I get my code that I'm editing on my machine into that container? How does it reload and actually show my changes? Be nice to do that. And then difficulty in debugging that QA environment. These were the primary drivers, again, behind writing this framework called SCAF that we're going to talk about today. Yeah. And so I said, Kubernetes to the rescue? That can't be right. Because Kubernetes, in most people's minds, I think has an impression of complexity, and they're not wrong. There are a lot of moving parts to running a Kubernetes cluster. And there's people who make a whole career of being an SRE or a DevOps engineer, and that's all they focus on. But I believe, I think we've shown, that you can take a tool like Kubernetes and through some other frameworks laid on top of it, hide a lot of that complexity. It may still exist, but the people who need to deal with that complexity can still deal with that complexity. And the people who need to code and develop new features for your application can focus on just being productive. So it's like shifting, obviously, complexity never goes away. You just shift it around, right? It's moved from place to place. It's not something you can. It's like a matter you can't create or destroy it. It all exists. Complexity is kind of like that in a software project. But if you can put the complexity in the right places and have the right people who know that that's their thing they deal with and it's not complex to them, then you've got a big win. And you can make developers more productive. So I do believe that we can actually use Kubernetes for this. And one of the reasons I like it is because it's declarative. You have a very explicit understanding of what is being deployed, when and where, and why. And actually, those same descriptions can be used on multiple environments. And there are some other tools like Kustomize that enable quick and thin layers of overrides, and I'll show that off here as well. So you are the architect, Kubernetes is the builder. I kind of say what I want. Kubernetes goes out and makes it happen, and then ensures that it stays happening the way it's supposed to happen in that cluster. There's no more manual commands for deployment. How many times have you ever had to SSH into a production server, CD into a specific directory, and type get pull, and hope and cross your fingers and hope for the best that main or master is currently not broken? That's not what happens here. In things like this, you basically, it's like the maintenance man in your new home. It actively maintains that state. So you tell it what you want to have happen. Get this version of our released software, which is in a container in this repository, and deploy it. If it can't make that happen, it will maintain the one thing that was there. So you don't end up in a broken state typically with Kubernetes. But it does require a little bit of know-how. And so for production, for example, on development, I think I'll show off here, it's pretty low overhead for those kinds of folks. So let's take a quick look at some YAML files, because that's what the declarative nature is going on in here. So this is the SCAF project. I've got the repository open up here on my local machine. So for example, if we looked at the Django YAML file in here, it's going to define some things like a deployment, a service, and so this actually patches in the Django backend deployment into our Kubernetes cluster. It may not make much sense to you now, and you don't want to have to deal with this necessarily, but that's why we wrote this framework of like scaffolding to put these pieces in place for you to make that all happen. So that's what Kubernetes is doing behind the scenes. I'm going to go over a little bit of Kubernetes terminology, so that for folks who maybe aren't as familiar. So don't get too scared. I swear it's going to be simple in the end when I do the demo. Now, I think the biggest win here, I think the main reason we would be looking at using Kubernetes across all these environments is because it does standardize the deployments. I think if you were still using some other tool on local and some other tool for production, you're going to be missing out on a lot of the value of this. So the big value here is that same underlying orchestration framework that works in production can run locally on my own machine in an actually pretty lightweight fashion. So it's the same tools to deploy in every environment. If something's going wrong in one, I can debug it because I know what it looks like in the other. It really makes that part easy. Application developers and DevOps engineers can speak that common language, but they don't have to necessarily do one another's job. I'm not actually advocating for the fact that application developers should become DevOps engineers. I think DevOps engineers should still do the DevOpsy things and the operational things, and the application engineers, application developers can now work nicely in that world, and when one needs to help the other, they're all familiar and comfortable with those tools. And then the last one, easily switching from that local and remote deployments or dev environments. And that was dev environments too. That's one of the key bits here that can actually help us solve that resource contention issue. If I'm running a local Kubernetes cluster and I've got a large stack of application that maybe uses 20 or 30 different containers that are deployed as various services, for example, you've got like Keycloak for authentication, you've got an LDAP thing running, you've got a database running, a Redis running, a Elasticache running, and you may have numerous services that make up what runs your app, but you may not have enough RAM, CPU, whatever it is to run it on your laptop. That shouldn't be a roadblock to you being productive. Remote dev environments means that someone could spin up a Kubernetes, the same exact thing in a public cloud, for example, like an Amazon or a GCP, leverage those cloud resources when you need that extra horsepower or memory, when you can't complete your task because maybe the tests require some amount of that stack to be available that you can't run simultaneously on your machine. You can still do it using these same tools across a public cloud, or a lot of people actually in our team have got a separate under the desk gaming rig or something like that they can actually leverage as additional horsepower to augment their laptop. And for a relatively low cost, and you're not obviously paying a subscription to have that thing on your desk, you're paying a little bit of electricity, but you can typically load it up with more RAM and even like a GPU if you're doing some kind of machine learning work that you may not have on your laptop. And so you can actually use these simultaneously to make this environment all work. So let's go over some quick things on Kubernetes, because I have a feeling that not everyone in the room is like a pro at this, and I would say I'm not either, but I want to make sure everyone knows the words when I go through and start talking about this. At its core, Kubernetes runs on nodes. So a cluster can be made up of one to some number of nodes, which is typically a virtual machine or like just a piece of hardware or a laptop. My laptop in this case would be my node. If you're doing production deployments, you're going to want to have like 3 to 5 type nodes, because you've got to have a whole bunch of considerations for like control planes, and that's where the complexity really like sets in. You're like, oh my goodness, this is a really big system, but it can run on just one node. You don't have to have 5 machines minimum to run a Kubernetes cluster, and that's what I'm running on here on my local machine. I'm actually running a Kubernetes framework called Kind, which actually runs in Docker. Like, you don't even need anything special. You don't need Docker to run Kubernetes. You don't need, I'm actually running OrbStack on my local machine, which I also recommend. Pretty cool tool. It's not free, but I think it's kind of worth it for your time. So in those nodes, you're going to be running various services. So the services you can think of as like the front end, like where it's going to ingress your traffic and send it back into some container to handle it. Those containers are your deployments, like for example, the React deployment, like for your front end, or your Django deployment for your back end. And then those run in pods. So the pods are going to run some number of containers to keep your application alive and serving traffic, and basically Kubernetes' job is keep everything healthy, keep everything looking the way you've defined it in your declarative configuration file, and away you go, which is kind of nice, because then now that we know what those actual words mean, it should be hopefully a little less scary. This is just an example with 2 nodes, running that deployment across the 2 nodes. Each of the deployments, for example, that pod is running 1 image, and it can have, again, a definition of n number of instances of that image, so it can scale as traffic grows. But as a developer, you shouldn't care about that. You shouldn't have to care about that until you run into some kind of performance problem on production where you need to now deal with maybe either refactoring your code or figuring out how you want to scale the application to make the best use of the resources that are available. So that's how your application runs in Kubernetes itself. The context and clusters, you can think of context as being a cluster. Like I've got a cluster and I can set multiple contexts locally on my computer to point at a remote cluster over here, the local cluster running on my orb stack, or some other cluster running in GCP, or the thing under my desk. That just gives me a quick and easy way to change my environment from the command line. And now I'm talking to QA. I think it would not be a good idea to have your developers have access to the production pods and clusters. But as an example, you can give them access to their preview environments running on an Amazon set of machines, so that you can actually have other people test, and you can share your work with others in a running fashion. So it's a way to kind of share a running version of the app quickly. But you can use cluster or these contexts to actually get quick access to run commands against them from remote. Like for example, I want to look at the logs, or I'd like to exec into that node or that container and examine some file and make sure it's doing what I think it's supposed to be doing. But obviously the most helpful one is being able to have quick access to the log files. Even in non-Kubernetes production environments, it can be really difficult sometimes to get access to those log files. And Kubernetes actually opens up that level of data and ability to triage issues to everybody who's involved. And then namespaces, because obviously they're one honking great idea. I obviously would love the Zen of Python. But the namespaces thing allows me in one cluster or one context to be able to run multiple versions of the same app if I wanted to. If you wanted to basically pull out 2 different branches of your if you're currently working on an application and run both of them simultaneously on your laptop without using containers, it would be difficult, because you'd have to set up alternate port numbers and names and things like that so that you can run them both simultaneously. Namespaces allow for this, because I can actually, without modifying the application itself, run multiple copies of it or multiple copies of a modified version of the application all in one cluster simultaneously. So if I had 2 different tickets or issues I was working on from the repository, I can have 2 different branches. I can be deploying those 2 different branches into 2 different namespaces and testing both of them simultaneously without having to think about changing port numbers and hand configuring, hand crafting configurations to make that happen. This actually is enabled by tools like Kubernetes pretty easily. So there we go. Well, then why wouldn't I just use Docker Compose? Because I think it's a simpler tool. I would agree with that statement, but it also has some sharp edges, especially when you're talking about cross-platform. That's where I started my container journey. I was like, man, Docker Compose is awesome, because I can sit and just be like, hit the Redis server. It's just called Redis. And so from your Django application, you configure your Redis cache, and it's just called Redis, and the things all just work internally, which is really nice and very easy. Same thing for the database. The issue came in with permissions and users, and it just never matched what was going to deploy into production. You could use Docker Compose in production, but then you're still going to shell into a machine and run some commands to update that configuration of Docker Compose to do a release of software. And I didn't like that. One of the true powers of Kubernetes is going to be the control plane. The fact that I can talk to it from an API. My CI or CD deployment environment can actually make decisions based on pass or fail, and to roll something out or roll something back without me having to put my hands on a keyboard and type anything like a git pull and have scary things potentially happen. So I kind of voted against Docker Compose and 4 Kubernetes even locally, just again normalize that environment across everything. So now, while you're all here, and we only have 10 minutes left, is the live demo. What I want to show is this tool actually in action, and we will make this happen. So we're going to head over here. Oh, you know what? For the funs of it, there are no files or folders in this desktop PyOhio folder. I have nothing up my sleeve, nothing under my hat. We're going to do a live demo with actually no files existing on here. So we're going to run our SCAF tool, and we're just going to call it PyOhio demo. Actually, okay. So it's based on cookie cutter. So what you should see here, you should be familiar with if you've ever used cookie cutter. It's going to ask you some questions about your project. PyOhio demo. And away you go. I'm going to answer most of the defaults here, but you can obviously customize for your needs. We can make different kinds of applications happen. For example, we're going to create a Next.js front-end application on our Django back-end application. We're going to use Mailgun. We're not going to use Celery or Sentry. We're not going to turn on debug mode, which is actually a confusing option that's going to go away. And we're going to use GitHub as our repository provider so that when I actually get this thing onto my file system, it's actually a Git repository ready to go and actually commit code and push. So I've even thought of that. Magic. So source control slug, we're in the 6vip org. We're going to call it PyOhio demo. And there you go. You can even see like the Git URL is all set for us. It actually puts it into the docs. So the README has all this information now filled out with all the templates and questions that are going on in there. Now, what's happening right now? It's actually created the file system, and it's actually running a pip tools compile of our base requirements so that, for example, if I'm starting a brand new, fresh Django application right now, I don't want to start with Django 4.1 something old that was like pre-specified. I actually am going to start with the latest version of Django right now. So it's using pip-tools compile to create compiled versions of my requirements files. I'll show those off right now. We'll go into that project. So on my back end, it is compiling these requirements. You can see the base.txt is that pip tools compiled version of all my cool stuff. Where the scaffold template just includes my main dependencies, my opinionated dependencies about how I'm going to develop this application. And it just includes, for example, just Django without a pin on it necessarily. I rely on pip tools compile to give me that pinned version of Django. So if I search in here for it's going to have a lot of them on there. Let's see here, it starts with Django. There we go, like all auth. There are 507, so that's the latest, stable version of Django is being automatically included into my environment. All right, that's done. So all I've done so far is this is like starting a brand new project even, not even a new developer coming in and doing a git pull. This is like, I got a brand new project I'm kicking off today, and we're going to go into that directory. I use dirinv extensively to make sure that environment variables are set correctly for this project across every developer who's using it. We'll use things like secrets. In this case, our secrets are stored in 1Password. They're never actually stored. Let me open this up a little more so you can see it. Here we go. If I do env grep AWS, those are all 1Password URLs, so there's no secrets currently in my environment. If I wrap any command with the 1Password run, it will negotiate and actually figure out those secrets and ask me to authenticate. So this way I have 0 secrets on my system. Again, 0 secrets in my code, which is also really, really helpful. And now, all I've done is create the skeleton. My goal is to run the tilt command. So tilt is another amazing tool for working with Kubernetes on a local development basis. It gives me the ability to, in this case, it's firing up a whole cluster. So if you go to the browser, it's going to be this. There's a there we go, tilt. You can see right here. Actually, everything's already up and running. It's very fast. It has all my Postgres, Redis, Mailhog, front end and back end all running. Tilt, you actually can see Django's already up and running. That's how fast Kubernetes is at like getting these containers going. Your first run mileage may vary because I have a lot of things cached. I did not delete my cluster in my Kubernetes because if I deleted that whole cluster, I would have deleted the local repositories that had the local images. But once things are cached, I can blow this away, start over, and within 60, 70 seconds, I am back running live again with a clean slate. Just what I just showed right there. That takes about, like I said, 67 seconds, 60 to 70 seconds, depending on your internet connection speed, because it's doing the pip compile was the longest part of this whole thing, because it's actually going out to PyPy and figuring out what dependency versions and doing all the dependency resolution and making that happen. And then running it is a breeze. So once I've got it live, we can actually go into localhost here. Here's my running Django instance. This didn't exist on my file system before. Before I can do anything, I still need to create a Django admin user. Let's do that real quick. It's also got some nice tools, like for example, if I want to shell into the backend, I've got a bunch of make targets set up to make this easier so that everyone has the exact same commands on every system they're on. So now I'm actually in my Django backend container. I've just basically kubectl exec into it, and I'll run manage create superuser. And I'll try and spell it correctly. It's a terrible password, I know. It's cool. All right, now if we go to sign, actually we'll sign in to the Django admin because that's also set up by default in our template. And there we go, we're signed in to Django admin. We can now view the site. I can actually change this documentation as a way as a quick start for a new project. If I want to now develop on the project, let's go back into those. This is the Django stuff, not even the front end. Like this front end's a Next.js app sitting on top of this, talking to it over GraphQL, all wired together, all working for you. Just kind of start developing, and away you go. Let's go into that about page. Let's just go into base. That's all the nav stuff here. Where's that? There we go. So I changed the word to page. It should sync. Yep, so I refreshed the page, and I got live updating of the code on the Kubernetes cluster. Tilt is watching my local file system and syncing those files into the Kubernetes cluster for me. So I'm developing on my local file system, dealing with all my local tools, my local Git. If I want to use some special cool Git tool that I like that no one else uses, no problem, it just works. The one last demo I want to try and do in the next 3 minutes is show you how to set up a remote debugger breakpoint in the code, which I think I could do. It's going to be tight. The README will actually show you how to do this to set up your debugger. And there are basically 2 lines we'll copy here. And we'll create a debugger environment. This one's specific for PyCharm, but you can do the same thing for VS Code if you wanted. We'll just set up a Python debug server for the backend. And we'll have it bind to all interfaces. That way we can get to it from our Kubernetes cluster. OK. And then we'll start our debug cluster. We should see down here. I think the fonts are too big. There we go. So now we've got a debug instance running locally on my laptop that my Kubernetes cluster is going to talk to. We will actually open up the app config. And we will turn on the debug. Close that for now, to PyCharm, because we can support multiple debuggers in here. And once we do that, we can now go into our Python code for a view, for example, and we'll paste in here underneath get object. Oops. Shoot. I got this. It's going to happen. Where's my debug stuff? Shoot. Maybe copy it again. Yank. Paste. Set a breakpoint, just like you would set. Oh, I think I got not enough of my thing. It's so hard to see on this little screen. Okay. The one last thing you have to remember to do as a part of this in Tilt is you'll have to reload the container. This little button right here to trigger the update actually rebuilds the Docker file and reloads that Kubernetes app config context into the cluster. And then in 2 seconds, we should have our, yep, we're ready to go. It deploys that container and it's up. And now if we go over to our PyOhio demo and we attempt to see my profile and click on my admin, my info, see that it stopped, it didn't go to the page. Come back over here and look at our debugger. It will be sitting at the debugger, ready to go for us to check our breakpoints out. And if I go back here, there we go. There's our breakpoint. That's hard to see. I'm sitting there with all the coolness of an actual debugger ready to go to inspect my stack. And that, folks, is the magic of all this. If I can now find my slides. If you have questions, there's a repo, there's the slides, there's me. I'm happy to answer any questions out in the hall. I think we've got a few minutes. I'll go out in the hall so the next speaker can get set up. I want to thank you all for being here.